So for experiment 2, we'll just be doing the calculation, the exercise, and the conclusion in the journal. You don't have to do a lab report for this. Okay, so let's start with the result section first. So let's say this is my result for part A, part B, and part C. So remember class that gross reading is not included in any calculation because this is just your titration in order to find out the initial endpoint. So we're gonna start with initial reading of 0.00 because you already fill up the burette with sodium hydroxide. So to find the volume of sodium hydroxide used, okay, it's just the final reading minus the initial reading. Okay, so for all my titration, I didn't start the consecutive titration with initial reading of 0.0, and that should be fine because it's up to you. So first, you need to figure out the average volume of sodium hydroxide used, and that would be the average of your first, second, and third volume of sodium hydroxide used. So 26.15 times 26.10 times 26.00 divided by 3. Remember that we don't include gross reading in any calculation. So that would be 26.08 ml. The most important thing in here is that you need to include all your results or all your data in 2 decimal place. Okay, because we are using direct. Okay, so your calculation and your finances should be in 2 decimal place as well. So move on to part C. So the average volume of sodium hydroxide used would be the average of first titration plus the second titration plus the third titration divided by 3. And that would be 23.72 ml. So let's say in your practical test, you haven't been able to got the third titration. Okay, so your average volume would be the average of your first and second titration. So that's how we want to calculate the average volume of NaO used. Next part is calculation. So for part A calculation, so the first one, you need to find the mole of hydrated oxalic acid. So for my result, I got 3.0000 gram of hydrated oxalic acid divided by the molar mass 126 gram per mole. So my mole would be 2.38 times 10 to the power of minus 2 mole. And the second thing for part A is to find the molarity of hydrated oxalic acid. So we're gonna use the formula of mole of solute divided by volume of solution in liter or dm cube. Dm cube. So my molarity would be 2.38 times 10 to the power of minus 2 mole divided by 250 ml of hydrated oxalic acid that we've prepared in volumetric flask. So convert the volume to liters. So divided this with 1,000. Because remember class that we prepared the hydrated oxalic acid in volumetric flask, which has a volume of 250 ml. So the molarity would be 0.0952 molar. For part B, okay, first you need to figure out the balanced chemical equation between sodium hydroxide and oxalic acid. Remember class to include the state or the phase as well because you're doing the experiments, so you must know about it. So second thing, is to find the molarity of sodium hydroxide by using the formula of mole of NaO divided by volume of solution in a liter. So how we're going to find it is by, first we're going to find the mole of sodium hydroxide by using stoichiometry, and the volume of solution is the average volume that we've already calculated in result part. So moving on, so mole of oxalic acid H2C2O4, we want to calculate it by using mv over 1000 formula. So 0.0952 molar times 25 divided by 1000. The reason why we are using the the volume of oxalic acid of 25 ml, because this is the volume that we use in part B, which is we pipette 25 ml of standard solution of oxalic acid. So your mole of oxalic acid would be 2.38 times 10 to the power of minus 3 mole. So now compare it with the mole of NaO in balance equation. So from equation, 2 mole of sodium hydroxide is equivalent to 1 mole of oxalic acid. So 2.38 times 10 to the power minus 3 mole oxalic acid would be equivalent to 4.76 times 10 to the power minus 3 mole sodium hydroxide. So now we already find the mole of sodium hydroxide. So next we can figure out the molarity. So that would be 4.67 times 10 to the power minus 3 mole divided by 26.08 ml. Okay, so remember class that you need to divide it with 1000. So your final answer would be 0.183 molar. For part C, the first thing first, you need to figure out the balance equation between sodium hydroxide and hydrochloric acid. So the product would be NaCl plus water. Okay, so second thing is to find the molarity of sodium hydroxide. First, we've got the molarity already from part B. So 4.34 times 10 to the power of minus 3 mole. So from equation, 1 mole of HCl is equivalent to 1 mole of sodium hydroxide. So 4.34 times 10 to the power minus 3 mole sodium hydroxide. So the mole of NaO is 4.34 times 10 to the power minus 3 mole. So the mole for your HCl would be the same as well. So your molarity of HCl would be using the formula of mole solute divided by volume of solution in liter. So your molarity would be 4.34 times 10 to the power minus 3 mole divided by the HCl that we use in part C would be 25 ml. Which one you pipetted to be used throughout the experiment of part C? So the molarity would be 0.174 molar. For exercise question, you should answer it as the addition of water into the conical flask will not affect the result because the number of moles of acid that will react with the base is still the same. The reaction between the acid and base depends only on stoichiometric ratio. So for conclusion, the last part, you just need to answer two questions. What is the molarity for sodium hydroxide, and What is the molarity for hydrochloric acid? So that's all for experiment 2.